Hello and welcome to everyone in Physics Fire. Today we are going to do the third lecture of electrostatic potential and capacitance. In this lecture specifically we will see potential due to sphere. So potential, if you will see, due to sphere is divided into two parts. First is hollow sphere and then second is what? Solid sphere. Hollow sphere, if you will see, it is conducting, non-conducting, and even solid also, if you will see, that is what? Conducting and non-conducting. So we are going to see in this lecture is what? We will see hollow sphere. Inside the hollow sphere, what will be the potential? On the surface, what will be the potential? Outside also, what will be the potential? These three things we will see. Likewise, we will see for solid also. Let's start the lecture. So potential due to a sphere. Potential due to a sphere. Important, we have done in first chapter also, right? Those formulas we will use today. So basically we should know those formulas, right? Okay, so potential due to a sphere. I'm just writing the topic. Potential due to sphere. Okay guys, fine. So spheres, if you will see, right here, spheres. Spheres, if you will see, two types of spheres are we are learning here. First one is what? Hollow sphere, right? And second one is what? Solid sphere. Okay, hollow sphere and what? Solid sphere. Hollow sphere, if you will see, conducting and non-conducting. Right, here also what? Conducting and non-conducting. If you will see, one benefit is there for this two and this conducting, if you will see, all will have same derivation. This is not going to change. Potential due to inside, outside, on the surface, everywhere will be same. Only thing will change is non-conducting. Let's see why it will change. That also we'll see actually. If you will see here, potential due to what we can say, solid non-conducting spheres, we can say it is what? Dielectric, or we can say insulating also. Insulating, right? This thing we should know here. Okay, let's start. Surface charges and all we'll see here now. First we are going to see first case. You guys should write this, and one thing is important, you should make notes with me because I am not giving in PDF. Hopefully after 1-2 lectures I'll provide the notes also, but still you guys should write with along with me, so that is going to help you more. So potential inside and outside charged hollow sphere, or we can say what? Or solid conducting sphere, or we can say what? Solid conducting. Potential due to a charge hollow sphere, conducting and non-conducting both, right? This also we should know. Conducting and non-conducting, right? Of radius capital R, right? Outside distance, let's take what? Surface charge density is what? Obviously we know sigma. Let's see the derivation now. many things we have seen. So let's start. Plus q charge, 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 right? At the center one charge is placed. First is what we are finding, potential outside, potential outside, potential outside, right? Guys, potential outside, if you will find, let's consider somewhere here at point P we want to find. Okay, at point P we want to find what? Potential. Guys, before we had done in electrostatics, that what will be the electric field due to a point charge outside. So we can say kq by let's take this is r and this is small r, kq by r square. Okay, now we know the relation E is equal to minus of dv by dr, but we want to find potential. So can we write like this? Delta V, change in potential, is equal to minus E dot dr. Of course we can do, right? Okay, guys, now the problem comes that how we'll write the change in potential, right? So it's easy. Whenever you want to find potential, change in potential, no, you have only one point, like at point P you want to find, and then you don't have second point, then potential at infinity you take. This concept you use and enjoy. So we can say potential at P minus of potential at infinity. Now things becomes easy, right? Minus of kq by r square into dr, right? So dr by r square integration is what? Minus 1 by r. From where to where? Infinite to r. For what is there? Kq. So guys, what will be the answer? Kq, minus is also minus minus plus, infinite if you will put it will become 0, so 1 by r on. So kq by r. So potential at point P we got what? Kq by small r. That's it. No direction, no problem. Achha, dot dr, and this is what? Cos 0, right? Same direction. So that also we should take care. So we got potential at some point P is what? Kq by r only. Very good. Now potential on the surface, we know potential on the surface of the conductor is what? Always constant. So we can say directly it is what? On the surface is constant. So potential Vs, potential at the surface is kq by r. Now potential outside, that is important, right? Inside, potential what? Inside. Very easy only. Let's see. Okay. This no, I'll teach you properly. Let's see, like means with diagram. Everything I'm teaching you properly. With diagram, I can show you. I can make you feel. Yes, like this. So ultimately, this is capital R. Now R, small r is this. So here you are supposed to find potential, right? Guys, one thing you keep in mind in differentiation as well as integration, for continuous thing we can integrate or differentiate. Like in between break will come, then we cannot differentiate, we cannot integrate. Somebody will say like we want to find potential here, we cannot find all of a sudden here at this point a small r. Problem is like it is not continuous, but somebody will say just nearby this point, like outside, like capital R is the near, just inside that, right? So there we can find potential. That potential you find, then we can use. Let's see. Potential, we know electric field inside the conductor is 0. Yes. If it will not be 0, then what will happen? Charges is 0, right? If charges will not be 0, then it will constitute what? Current. It will constitute current. It will not remain what? Electrostatics, right? It will come something else. So the E is what? Inside is 0. E inside of the charge conductor is what? Okay, is 0. Okay, fine, very good. Now that we did, now we can say delta V is equal to E dot dr minus of that. Guys, at point P we want to find anyway, and that is the surface, right? So we can say just nearby the surface. Achha, just nearby the surface or on the surface is going to be same, right? That's why we are taking that. So Vp minus of what? Vs is equal to what? Minus of E dot dr. Achha, guys, what is E here? E is kq by r square, right? Into what? Dr. Finished. Now where to where ultimately? Ultimately, if you will see inside, right? So inside is, it is 0. Sorry, inside electric field is 0, right? Then why I wrote this? Inside electric field is what? 0. So potential at point P is equal to potential at the surface, just inside the surface. So Vp at point P inside also kq by r only. Okay, so now if you will see potential inside, guys, we'll see with graph. Electric field, if you will see outside is kq by small r square outside, right? Potential inside is what? Potential inside is electric, it is outside, right? Inside is 0. On the surface is kq by capital R square, right? That is about electric. Potential, if you see, outside is kq by R. Inside is kq by capital R. On the surface is kq by, on the surface, kq by R. Now if you will draw the graph, E versus what? E versus R graph. If you will draw the graph, guys, then it should be kq is constant, right? So constant. And then what happens? It decreases, right? Electric field, obviously it is decreases. Oh, electric field, no, electric field inside the conductor is 0. So till here it is going to be 0. Then maximum on the surface, after that it is decreasing, right? So maximum will be on the surface, after that it will decrease. Here if you will see, on the surface from like center to the surface is going to be what? Constant. After that it decreases. So this question many times they ask in JEE mains, NEET and all. So hope so you guys understood. Now this question is for what? Charged, solid, conducting, as well as charged, hollow, in conducting and insulating. Now we are going to see only one part, little tough, that is what? Potential due to a sphere, charge sphere, right? Charge solid sphere. So the case is what here now? Potential due to potential due to what? Due to a charged non-conducting solid sphere, right? Let's see. Radius is what? Capital R. Outside is what? Small r. Those things will be there. Guys, first no, we are seeing outside the surface. Outside we will find potential. Play the game outside. Okay. That is at point P we want to find potential. We know if it is a potential outside, then obviously electric field is equal to kq by r square. That is there always. Fine. Now the problem comes, delta V is equal to minus of E dot delta R. E is, guys, kq by r square in kq by r square into a dr, right? Kq by r square into dr. Anyway, cos same angle cos 0. Again, potential at point V you want to find, no, at point P. So Vp, right? Yes. So here is what? Infinite, right? And here is what? R. So as I told you before also, that whenever you want to find potential, and that to change in potential, and you have only one point, then that trick you can apply. That potential at infinity is what? Zero, right? So Vp minus of V infinite is what? Zero. So Kq will come out cos zero anyway, right? Same direction E and dr. So now Kq integration of dr by r square. So minus sign is also there. Minus of 1 by r. So potential is going to be Kq by r. That is what? At point P. Fine. So outside potential is going to be Kq by r. Very good. Now we are going to see inside. Right, on the surface we know potential on the surface is going to be, we'll see later, that is Kq by r always, right? So K potential, now potential inside the surface. This is little not tough, but fine. Let's see, we'll see. Potential inside the surface. Inside the surface, if you guys will see, then what will happen? Same thing will happen, whatever happened before, right? Let's see. Positive charges, right? Okay. Now let's see, somewhere here we are calculating potential, right? This is small r and this is capital R at point P. Let's see, this formula we should know. We had done potential due to a electric field due to a solid non-conducting charge. For that electric field we got KQ, if you remember KQ, what is that? KQR by think KQR by R cube, right? This will have to know, because last class, like last chapter, we had done this. So electric field is equal to KQR by R cube. Now potential again at point P. So the same way, delta V is equal to minus of E dot dr integration of this also. From where to where potential? Again inside, on the surface, just on the surface, right? And then at point P. So potential at point P, Vp minus of Vs, right? Why on the surface? So that we can do integration, right? Minus of E. E is what? KQR by R cube into dr cos 0 integration on the surface is what? Capital R, right? And then inside is a small r. That's it. Now if you want to do, we'll have to do integration, right? So Vp minus of Vs. Vs is what, guys? Vs on the surface is Kq by R. Now what is there? K minus of Kq by R cube. Whatever things are constant, that we can take out. Kq by R is constant, R cube is constant. So R dr is what? R dr, right? R dr is here, which will change, right? So from where to where, that also we should know. On the surface, capital R to small r, right? Minus of Kq by R cube. R dr integration is what? R square by 2. Okay, from where to where? Capital R to small r. So Kq by R cube minus of that R square by 2. Then you will put this upper limit minus lower limit by 2. So this is going to be Kq R cube 2R cube. 2R cube into what? R square minus of KQR square by 2 into what? R cube is equal to Vp minus of, not minus, directly write the formula, KQ by R, right? Okay, KQ by R. Just a minute, my pen is not writing. One thing we did mistake, right? See, that you have to see properly. This minus sign also will have to consider, right? Somebody would have understood also that I did mistake. So that calculation mistake can happen. Fine. So now anyway it is correct only. Before finishing the lecture itself I understood that I did. Because anyway answer will come wrong, then I'll understand. So we can say now kq by r square by 2r cube. R square and this we can cancel out, plus of kq by 2r plus of kq by r, right? Not p, this is r. Let's solve it. If you will solve here, then what you will get? Think. Now this is 2r. Let's solve. LCM, if you will take, what you will take LCM? Let's take 2r cube, right? 2r cube. 2r cube if you will take, then we can take kq common, and here it is going to be what? Minus of r square, here plus of what? 2r cube, here is a square, so r square you will have to write here, right? And then here also what you'll have to write, here is 2r square. So now we can say there is no capital R, so here is 2r square, 3r square. So kq minus kq r square by 2r cube plus of what? Plus of 2 and 1 3r square by what? 2r cube, right? That is what we got the answer. So guys, if you will take common kq by r, then this is going to be the answer. Fine. If you will draw the diagram for this, right? Like graph, not diagram. So the graph is going to be what? First, if you will see potential inside, what is happening here? Inside it is increasing. So inside it increase. After that, what? Obviously it is keep on decreasing. So this is going to be at the surface. After that, what will happen? It is keep on what? V is inversely proportional to 1 by r. We can say this is V versus what? R. This is at the surface. That's it. So these types of derivation some may ask, right? Like graph type of question they can ask you. Now we are going to do some few numericals, right? Let's see one numericals. 3 charged spheres. Write the question. 3 charged spheres, spherical shell, 3 charged spherical shells, right? 3 charged spherical shells are as shown. So let's see, this is radius RA, RB, RC. Center is O here. Now we want to find potential at potential what at A. First question, potential at B, potential at C. So potential if you want to find at A, B and C, now we'll have to think. So let's find potential at A. We'll use another color. Let's see potential at A. Guys, potential at A, if you will see, so on A, what are the potentials will be that we'll have to think. So guys, potential at A, if you will see in this point, obviously potential due to A itself, right? Potential due to A itself, correct. Now at A again, if you will see, due to B also, right? Right, due to what? B, which is what? Outside. Potential due to what? B, again due to C also, potential at A due to C. So potential at A is what? KQ by what? Potential at A is what? RA. Potential at B, if you will see potential at A due to B, right? So it is outside point. So there will be also a potential, right? What will be the potential? But think, as it is what? Inside, right? Potential at A due to what? C, inside point. This is also what? Inside point. So we can say KQB by RB, KQC by what? RC. So this is going to be the potential at A. Now potential at B, if you will see, so this will apply a potential, right? Inside point on the surface itself. C will also point inside. For A it is outside, for B on the surface, for C inside. So these three things again. So we can say at B, if you will see, that is going to be potential at B due to what? Due to, we can say, QB. Let's take first QB, surface point, right? Surface point. Potential at B due to A. A is inside, right? But for A it is outside point. So outside point. Potential at we can say C. Potential at B itself due to C is what? Inside point. That's it. Now potential at B, so KQB by what? KQB by RB, and again KQA, right? By what? RB. KQ what? KQ. Now at C due to what? RC. Now at C, if you will see, potential at C, so hope so you guys understood. RC. Potential at C, if you will see, C all will be what? Inside. Potential C due to charge QC, it is what? Surface. Apart from that, potential due to B, it is what? Outside point, right? And then potential at C due to A, again what? Outside point. Fine. So first one, if you'll see, KQC by RC, KQB by what? RC only, right? KQA by RC. That's it. So these types of question they may ask from here. Till here you guys revise. We'll see again in the next class, right? Different concept. Obviously, it will be a different concept.